next we're going to run a regression. So I'm going to data, data analysis, regression, and our Y range is going to be the net support here. Okay. I think I grabbed that one. Just Sheets and Excel do this in opposite directions. That's why I'm being a little cautious here. Yeah, I think what I had originally was fine, so you click in the cell first and then you select. I do have labels because I included this top. If I had only selected the data, I would not click that labels. If your answers are ever off by a little bit, you should check to make sure you're doing the labels box correctly. So again, if you include the column headers as part of your selection range, you definitely want to make sure that you check that labels. And if you don't want to check that. Otherwise, it'll count some of your data as labels. Okay, I'm getting some residual plots there. Just looking ahead, I think that should work. Click OK. And let's take a look at this. So here we're looking for a random scatter above and below. I'm not really seeing I mean, there seems to be a little pattern here going on, which again is what I think the question is going to explore. I do have a significant model here with a very, very high R squared and even the adjusted R squared, which for a small sample size we might expect a bigger drop here. But this tells us that we are fitting these particular points really well, to the extent that we're also fairly sure it would fit a larger group of points. But what we're really looking for here in the question is this output on months. So this is conducting a little test on months to see if it's statistically significantly different than 0, the slope here. And we do see that is well below 0.05. So months certainly is a significant predictor. And more specifically, drifting back to the language of inferential statistics, we're testing whether the slope, remember this is just an estimate of what the true slope of months would be in the population relationship, is the population slope different from 0. The null hypothesis, null meaning nothing, would be that it's not, that the slope is 0. The alternative would be that it's not 0. We would conduct this t-test. This would be our t-statistic, which is well over the threshold we would need. We could get the critical t from using the degrees of freedom here, but it would be something like 2 point or 3 point something. So this is well beyond that critical t, which allows us to reject the null and say that the slope in the population is significantly different from 0. In other words, we have a time effect. That's another way of saying it.